Welcome to Techflix. In this video, we would discuss in details what are the input and output modules of PLC and how they work. In previous video, we have discussed in detail about CPU and power supply. If you compare the PLC to the human body, the CPU is the brain of the PLC. It takes inputs and thinks and make decisions. Like brain, the CPU in PLC will give output to perform certain tasks. Like a human body takes input through sensory organs, the PLC takes inputs through input modules, and like human body gives output such as muscle action, the PLC gives output through output cards. These are known as IO modules, or input-output modules. So basically, PLC have four primary types of IO modules. Digital input module, digital output module, analog input module, analog output module. So, the digital input module takes digital input from sensors such as push button, proximity switch. A proximity switch is used, mainly on conveyor systems, to count anything. When anything comes in proximity of the proximity sensor, it sets the output high. Limit switch. A limit switch is used commonly on elevator systems. When elevator hits the limit switch, it sets the output high. So, the analog input module takes analog input from sensors such as pressure transmitter. The pressure transmitter converts the pressure into electrical signal and sent to the PLC in 4 to 20 mA analog signal. Level transmitter. Similarly, like pressure transmitter, the level transmitter also provide the PLC an analog signal in form of 4 to 20 mA. RTD. The resistance temperature detector is a temperature measuring device which gives change in resistance with respect to change in temperature. Digital output module gives a digital output signal of 5 to 24 volts DC, which can be relayed by a relay. High voltage such as 230 volt can be relayed using the control signal from digital output module of PLC. The control signal from the digital output module can be also given out by a transistor. The analog output module gives out analog signal, that is a continuous signal, instead of on and off. The analog output module gives out analog signal, which can be relayed further with contactor. Now the contactor are similar to a relay. But contactor are robust, which can handle high continuous analog signal, such as required to drive VFD for motors. The analog output signal can be also given through a triac. The triac is similar to a transistor. But the triac can handle voltage in range of 230 volts AC. It uses the control signal at its gate to allow the higher voltage to run through it and power the output devices. A solid-state relay can be an alternative for triac. We know how an analog signal is converted to a quantized DC signal. This quantized signal will have various levels, such as at time 0 second, the signal has 5 volts, at time 1 second, it will have 10 volts. So now this different levels has to be converted to binary bits. Since the processor of CPU understands only binary data. For this purpose, we need ADC. Analog to digital converter. Now ADCs are of many types. We are discussing the Successive Approximation Register or SAR. SAR, as the name suggests, it does a successive comparison between the input signal and a reference signal to generate binary data. Let's consider the reference voltage as 15 volts. So for 15 volts as reference voltage, all bits will be high when input voltage is 15 volts. So, let's consider the input voltage is 13 volts. Now the binary bits would be approximated accordingly, and some certain binary bits would be high, as shown. In this way, the SAR compares input voltage and reference voltage and produces binary bits. Now, the resolution of the approximation depends on the number of bits are used. More the bits, high the resolution. For example, in this case even for 13.8 or 13.5 the output would be always 13 volts. So this is a 4-bit ADC. So now, we know how an analog signal is sampled, quantized and converted into digital signal. So the analog input card receives 4 to 20 milliamperes analog signal from transmitters of sensors. This analog signal is sampled, quantized, and given to the ADC. Output of the ADC is now checked for a safety limit using the Zener comparator. Now when the signal is within the limit, it will pass through a light-emitting diode to give out light. This light will trigger the gate of the transistor, instead of a current signal. This is known as optical isolation. Optical isolation protects the sensitive processor from direct contact of current coming from the ADC. A digital input module of PLC works in similar manner as compared to analog input module. But since the digital input module receives digital signal already, so the ADC is not required. The input signal is now filtered and checked whether it is in the limit using the Zener comparator. Once the signal is filtered and is in limit, it will pass through the light-emitting diode. The light-emitting diode will generate a light pulse which will trigger the gate of the transistor. So now the processor received optically isolated digital signal to process. So now, we know how transistors and TRIAC works. Now let's discuss how the analog output module works. After the processor in CPU runs the program and generate output. These outputs are sent to the analog module to operate the output devices. Now, the analog module consists the circuit as shown. It works in the similar manner, like the input modules. The output from CPU goes to the light-emitting diode in the analog output module, and hence produces light for each high pulse. This light acts as a gate pulse for the light detecting element, which in turn result in providing gate current to the gate terminal of the TRIAC. So once the TRIAC receives gate current, the AC current can now flow through the TRIAC and power the load. The DC output module works similarly like the AC output module. The output of the processor in CPU goes to the DC output module. The DC output module consists the circuit as shown. The output from the processor in CPU goes to the light-emitting diode. The light-emitting diode emits light pulse, corresponding to the digital output from the processor. This light pulse triggers the light detecting element, and it in turn allows the DC current to flow through the base of the transistor. So now the current can flow through the collector terminal of the transistor to drive the load. That's all folks, hope so you have learned something in this video. For more videos, subscribe to our channel and hit the bell icon for instant notifications. Jai Hind, Jai Bharat.